Our project is about object tracking using morphological operators. I myself, Ashwath Gangreddy, Vaishnav Podilla, Hemtarang Katamanchi are the teammates to design this project. Introduction. Object detection. Detecting a specific object in an image. Object detection is a process of finding instances of real-world objects such as face, bicycle, and buildings in an image or a video. Object detection algorithm typically uses extracted features learning algorithms to recognize the instances of an object in a particular category. Object tracking is a process of locating moving object over a time using a camera. It has a variety of uses, which are human-computer interference, security, surveillance, video communication, augmented reality, traffic control, medical imaging, video editing. It is it is a time-taking process because it contains large amount of data. We could look onto the applications of video tracking which involves surveillance, vehicle tracking and mobile vision for mobile robots. Methods of object tracking. We have different methods for object tracking. One among them is differences method. In differences method, we have a reference video frame that has an object which will be compared with the actual video frame. If the object is detected, it shows object using background subtraction technique. Background subtraction technique will be helpful in determining the concentrated object without considering the background to be in short. In this method, the difference between two frames in the video will be checked and the object is filtered. Uh, to do this, a difference filter is used in OpenCV for object tracking. For better understanding of difference method technique, you can go through the link below. But in this, we have very high complexity of mathematical calculations and we have to make a note that it cannot be implemented in DSP, which is digital signal processing. Let us go to the example. Here in this slide, we can observe two frames that has different objects. In the both frames, our aim is to extract object through difference method technique. Frame 1 is a bit darker than frame 2. Frame 2 a little bit brighter than frame 1. So here we can observe there is a difference in threshold values. This can be a deciding factor for image extraction. And after subtracting the background, we can identify the object more or less. But it involves very complex mathematical calculations and requires more computational time. Let's go to second method, which is census transform. Census transform is a method of tracking method. Here the entire image was divided into weighted codes such that we will take the center weighted code will be taken as a reference. If the neighboring pixel has weight greater than the center pixel, then it can be considered as 1. Else, when it is less than center pixel, then it can be considered as 0. From this, we can generate a signature vector. This can be done by using clockwise direction as shown in this video. Let us go into the second image for better understand second slide of census transform for better understanding. We will do the same process for the second frame. In the same way, we will generate a series of signature vectors and these signature vectors will be compared with the first video frame. If the signature vector matches, then our object is filtered, else it is not filtered. Advantages are it is easy to compare a binary digits over because it's zeros and ones than comparing the whole hexadecimal codes. This is the method we have to use a central pixel with the neighboring pixel which has a less complexity. than the others. Disadvantages: it contains large number of salt and pepper noise because we will find a group of ones and zeros together uh, very near. Complexity: we have a large complexity because uh, each time we have to take binary digits, zeros and ones, and compare those binary digits, so it takes a large time, which results in a large computational time. Method 3 for object tracking. This process partly used in our project. It involves foreground and background subtraction, which will be discussed in detail. Background subtraction is also known as foreground detection. Is a technique in the fields of image processing and computer vision, where in an image foreground is extracted for further processing, such as object recognition, etc. Generally, an image regions of interest or objects such as humans, cars, text, etc. in foreground. After the stage of image processing, which may include image denoising, post-processing like morphology, object localization is required, which may use of this technique. Background subtraction is also widely used approach for detecting moving objects in videos from static cameras. The logic in this approach is that detecting the object from the differences between current frame and a reference frame, often called background image or background model. Background subtraction is mostly done if the image in the question is a part of video stream. Background subtraction provides important clues for numerous applications in computer vision. For example, surveillance of tracking or human poses estimation through a process called edge detection and thresholding. Edge detection is a set of mathematical methods which is aimed to identifying points in a digital image at which image brightness changes sharply or more formally as discontinuities. The points at image brightness changes sharply are typically organized into a set of curved lines termed as edges. The same problem of finding discontinuities in 1D signals is known as step detection, and the problem of finding signals in discontinuous over time is known as change detections. Edge detection is a fundamental tool in image processing, machine vision, computer vision, particularly in the areas of feature detection and feature extraction. Let's go to thresholding. Thresholding is replace each pixel in an image with a black pixel if the image intensity is less than the fixed constant t. White pixel if the image intensity is greater than fixed constant t. Mathematic morphological operations. Morphological operations is a theory of technique for the analysis and processing of geometrical structures based on a set theory, lattice theory, topology, and random functions. Morphology most commonly applied to digital images, but it can be employed as on-graph surface meshes, solids, and many other spatial structures. Topological and geometrical continuous spaces concepts such as size, shape, convexity, connectivity, geodesic distance were introduced in morphological operators on both continuous and discrete spaces. Morphological operators is also foundation for morphological image processing, which consists of set of operators that transform image according to the above categorization. The basic topologies are operators are erosion, dilation, opening, and closing. Let's quickly go into object tracking. Object tracking is used to track the objects. The point tracker object tracks a set of points using Kennedy-Lucas-Tomasi feature tracking algorithm. You can use a point tracker for video stabilization, camera motion, estimation, and object tracking. It works particularly well for objects that do not change shape and for those exhibit visual texture. Point tracker is often used for short-term tracking as a part of large tracking frame network. As a point algorithm, point can be lost due to lot of variation of out of plane rotation and articulated motion. To track an object over a long period of time, you may need to require point directly. Mathematical MATLAB program. First, initially, input is acquired from the camera connected to the computer. After image acquisition, MATLAB, this acquired image is added to the MATLAB program where object detection is done. From here, I'm going to hand over to my friend Vaishnav Podili. The details of video are acquired. Then the video is converted into HSV. Hue is an image. Hue of the image is extracted. Texture of an image is also known as a standard filter. Edges are detected using range filters. Morphological operations. After determining the edges, we choose a particular threshold value. Any pixel that has an intensity lower than threshold will be discarded. Problems after applying threshold. Lane markings still remain in the image. Using morphological processing, an object smaller than that particular value will be discarded. Stel is a function used to remove lane marking. It creates a structural element like balls, squares, line in this project. Here in this project we used a disk. In the next step, the function IMOpen is used. This command does an erosion followed by dilation using the same structure element. For both the operations. Object tracking. Once remove all the other objects in the frame, we get an area and a centroid for the car in the frame. The object with largest area is the car. Create a copy of original frame and tag the car by changing the centroid pixel value to red. This tracks the different cars in the video frame. Now we are going to hand over my friend Hemtaran Katamanchi will continue the rest part. Flowchart of morphological based on object tracking, which is a series of steps. Initially, when it starts, the hardware system associated will be turned on. Video extraction or acquisition is made possible through image sensors. Once it is image is acquired, it is first thresholded, which subtracts the background. And using morphological operations, we could track the object. If object is found, then we will terminate the process and we will display the particular object. Else it would be further thresholded and the process is repeated several times until the object is detected. Let us quickly see in working model. In this image, in this working model, first the image is converted into HSV. It would be better beneficial because in order to understand image a bit detailed than RGB, and later on we could extract the textures. Image texture gives us information about spatial arrangements of colors and intensities in an image or a selected region such as road lanes, etc. Image when edge extracted. These points at which brightness changes sharply and typically organized in a set of curved lines segments termed as edges. Here we can observe the curve segment which is an edge. and all the three are can be observed in a single image of which has a range, standard filter and textures. Let us check in the two video frames. I have two videos in order to check the how good it works. So I have two video frames. In first image, you will be able to detect a car. In the second image, you will be able to detect a car in two different views. Let's check with this. So here it is only based on the video frames, set of video frames, and the set of threshold value. Only it has a probability of detecting using the definite set of frames and the fixed threshold value. Else it could not be able to figure out it. Results. Difference method performs a logical operations of 4,23,000 42 lakh 30,100, whereas census transform method performs a logical operation of 24 lakh 16,000, whereas morphological operations performs a logical operations of 33 lakh 52,210, which is very less, and we have less complexity than the other two methods. It has a result. It gives a results within 14 milliseconds. Conclusion. Conclusion. The morphological operation using background subtraction technique scheme gives most promising results in terms of detection, quality, and computational complexity to be used in real-time surveillance system with more than dozens of cameras. However, no object detection algorithm is perfect. So our method, since it needs improvements and handling darker shadows, sudden illumination changes and object occlusion, high-level schematic extraction steps would be used to support object detection step to enhance its results and eliminate inaccurate segmentations. Here we can find the references what we used for our project. It is detailed. I don't want to explain this. Thank you. Have a nice day.